Hi class, this is Dr. Karsten, and today we are going to be doing lesson 32, and this is from Module 5, Grade 4 of EngageNY Math. So for this lesson, we are going to be subtracting fractions from mixed numbers. So this is going to be very similar to the last couple of lessons. Again, I'm going to be doing it in a few different ways, and you are going to be able to work with this the way that you are the most comfortable. So let's get started. So we're going to start with a nice easy example. So our first problem is going to be 3 4/5 minus 3/5. So I'm going to be doing this a few different ways. The way that I really want to start is actually with a number line because that's really going to model it visually for us. So let's go ahead and draw a number line. And for this one, you can see that I'm starting at 3 4/5, which means that I really want to have a 3 and a 4, but 3 is going to be kind of where my middle is. So I'm going to put my 3 right here. I'm going to want to go up to 4, and I'm also going to want to go down to 2. Now for our problems, we're going to be fine if we just go ahead and we go down one number down. So whatever your starting number is, in this case it's a 3, I'm going to go one number up and one whole number down. And then what we can do is I'm going to go ahead and mark in my fifths. And the reason I'm doing fifths is because I have a 5 in the denominator. So whatever you have in your denominator, that's what you're going to be marking off. So I'm going to go ahead and do my best to mark off some fifths on here for us. And you can see that I have 1/5, 2/5, 3/5, 4/5. Once I get to 5/5, I'm actually at the next whole number because 5/5, this is our rule for this problem, 5/5 is equal to 1. Remember, our rule is always based on our denominator. Now let me do the same thing down here. So I'm going to mark off my fifths. And you can see I would have 2, which would be 0/5. 1/5, 2/5, 3/5, 4/5, and 5/5 would get me to my next whole number because, again, I've added one whole on there. All right, so now let's go ahead and let's mark on here where we are starting from. And we are starting from 3 4/5. So 3 is my whole number, so I'm going to start at the 3. And then I have to go up 4/5 from that. So that's going to be 1, 2, 3, 4. Now, just so you know, for this particular problem, we are actually not going to go to the other side. Sorry, guys. Okay, sorry about that. Puppy got into something. Okay, so for this particular problem, we are actually not going to go beyond the 3, just to let you know, or go lower than the 3. But it's still a good rule for us when we're doing this, just so that you know how to set up. So back to where we were. We started at 3 4/5, so we have 3 and 1, 2, 3, 4/5. So I'm going to write that for us. And then we want to subtract 3/5. When we're subtracting, we're going to move to the left. We're going lower or smaller. So we're going to go to the left. And what are we going to do? We're going to hop 3/5. So we're going to go 1, 2, 3. And this is where we're landing. We want to model that. We have our starting number. We want to model that we're going to the left, and we want to show what we did, which was subtract 3/5. And so now we have to figure out where we landed, and we landed at 3 1/5. So this is 3 1/5. So that's the first way that we can model this problem. We can show that we have a number line, a starting number, which was 3 4/5. We can show that we moved to the left 3/5, which was this, and then we can show where we landed, and we can go ahead and write our answer. So that's going to be equal to 3 1/5. So now let's just talk really quickly about another way that we could have done this one. Another way is you could have just seen horizontally that since 3/5 is less than 4/5, I could have just said 4 minus 3 is 1. 1 what? 1/5. We have fifths. Remember, when we're subtracting, we keep the denominator. When we're subtracting, we need to have common or like denominators, and then we just hold on to that denominator because it's like a label. And then since we were able to just take those 3/5 away from the 4/5, we would hold on to our 3. So there's another way we could have done this, which is what I was starting to do with you, which is that instead of doing it horizontally, we could have done this problem vertically. So we could have started with 3 4/5, and we could have subtracted 3/5 from that. So this is similar, because remember we want to line up our common units here, right? So we're lining up our fifths and we're lining up our thirds. So another thing that I could have done, sorry, I'm a little distracted here. We have people running around. I want to just compare this to doing another math problem. So let's say that we were subtracting, let's say we had 35 and we were, or let's even better, let's do 34 and we're subtracting, let's do 13. So first you would do your ones, so you do 4 minus 3, so 4 ones minus 3 ones leaves you 1 1, and then you would have done your tens. 3 tens minus 1 10 would leave you 2 tens, which is 20. So we'd have 21. So similarly, when we're doing fractions, we're going to first work here with 4/5 minus 3/5. So 4 minus 3 is 1. 1 what? 1/5. And then 3 minus nothing would leave us with 3. So either way, we're getting the same exact answer. We're getting 3 1/5. So 3 1/5 doing it vertically, 3 1/5 doing it on a number line, and 3 1/5 when we did it horizontally. So let's go ahead and let's take a look at another problem. So this one's going to be a little different, and you'll see why in 1 second. So let's say that we were doing 4 1/5 minus 3/5. So now if you look at this straight off the bat, you can see that I only have 1/5 and I cannot subtract 3/5 from that. I can't just say, oh, 1/5 minus 3/5. It's not going to work. Hold on, we got a puppy being noisy. So let's take a better look at this by modeling this with a number line, because that's really going to help you to see what the problem is here, but it's also going to show us some solutions for how to deal with this. So I'm going to draw my number line. And again, I'm going to put my 4, since that's where I'm starting, right in the middle. And then I'm going to put my 5 and my 3. So remember, I'm going to, whatever number I'm starting with, I'm going to put that right in the middle, and then I'm going to go 1 up and 1 down, one whole number up and down. So now let's go ahead and I'm going to mark off my fifths. And the reason I'm doing fifths is because I have a 5 in the denominator, so we're working with fifths. So I need to mark those off again. So again, I have 1/5, 2/5, 3/5, 4/5, and once I get to 5/5, we know that that's equal to 1. My rule is going to be based on my denominator. So if I need this rule, I have it, that 5/5 is equal to 1. And now let's go ahead and let's write it down here as well. So we're marking off all of our fifths. So again, 1/5, 2/5, 3/5, 4/5, 5/5 gets us to 4. So let's now show where we are starting. So we're starting at 4 and 1/5. So remember, that's just like saying 4 plus a fifth. So here's my 4, and I need to go up 1/5 more. So 4 plus a fifth lands me right here. So this is where I'm starting, at 4 and 1/5. Now what you can see is that once I get down to this 4, I've run out of the fifths, but I need to do 3/5. So let's just really easily first show it on the number line. So I have to go down 3/5, so I'm going to go down 1/5, which gets me to the 4. And then I'm going to go down 2 more fifths. 1, 2. And I'm going to mark it right here. So I want to show what I just did, and that we went down 3/5, so minus 3/5, and we landed at 3 and 1, 2, 3/5. So that's going to be our answer, 3 and 3/5. So now let's talk about a couple of ways that we could have done this one if we were working on it and we were not using a number line. So we're going to work on it both horizontally and we're going to work on it vertically. But we're also going to think about a couple different ways that we could work with this. So the first one is that we are going to take that 3/5 and we're actually going to decompose it. And I'm going to show you how we're going to do this. So let's start. We're going to have our 4 and 1/5 minus 3/5. And if this way doesn't work for you, don't worry. I have a whole nother way that we're going to do this, so don't stress. We're going to do this a bunch of different ways. So the first way that we can do it is that we can first show how to get down to that 4. That to go from 4 1/5 down to the 4, we had to get rid of this 1/5. So what I want to do is I want to pull out 1/5 from the 3/5. And then I can see what that's going to leave me, which is 2/5. So we have 3/5. We're going to first show this part of it, this 1/5. So that's right here. So 3/5. So I have 3 of them. I put 1 here. And I would have 2 left. 1 plus 2 is 3. 3 minus 1 is 2. So now what I can do is I can say, well, this 1/5 and this 1/5 are going to be gone. They're going to cancel each other out because I'm taking away or subtracting 3/5, and that's part of it. So we're going to first show this hop. So that leaves me then with 4 minus the 2/5. So I just want you to kind of imagine that. So we had 4 1/5 minus 3/5. First we got ourselves down to the 4. We hopped down 1. That's 1/5, which means we had 2/5 more. So then we can just take that 4 and say, well, what's 4 minus 2/5? And what you can think about is this 4. So I'm going to just first write this. So we're left with 4 minus 2/5. Now what you can do is you can think of this 4 really as 3 and 5/5. Where did that 5/5 come from, you might be asking? Well, first of all, I know that I'm dealing with fifths. I needed to get a common denominator. And what I'm doing here is, you can see I'm pulling that apart. My rule was that 5/5 is equal to 1. So really what I just did was I pulled this 4 apart into a 3 and a 1. So this is 3 and 1 is 4. Remember, 5/5 is just 1. And now I can subtract that 2/5 from that 5/5. So I'm going to hold on to my 3. And I'm going to do 5/5 minus 2/5. 5 minus 2 is 3. 3/5. So again, what I did was, first I took away that 1/5, and then I went down 2 more. So that's another option. That's another way that we could do this, is that we can first get rid of whatever the fraction is, subtract out the fraction. So we did that. Let me go ahead and just kind of mark that to show you. We did this part of it. And then what we did was we took this, the 4/5 minus the 2/5, and we showed that, and we pulled apart, we decomposed this 4 into 3 and 1, but instead of writing 1, I wrote 5/5, and now I can just work with this part right here. So 5/5 minus 2/5, which gave us 3/5, and I still had my 3. So that's another way that we can do this. Let me show you the third way, which is going to be the vertical way. But this is going to be a little different. And this might work for some of you. Again, for now, you guys get to pick whichever way works best for you. So let me write what we're starting with. We have 4 and 1/5. And you can see I'm giving us a little bit of room to work with here. And I want to subtract 3/5. And again, I just want to really give us room to work. So what I could say, now let me show you something on the side over here. Let's do a similar problem that you would be more familiar with. So let's say that I had to do 41 minus 3. What would we do? We cannot subtract 3 from 1. We can't say 1 minus 3. It doesn't work. If I have 1 lollipop, I can't give you 3 lollipops. But the reality is that we have these 4 tens. We can decompose. We can pull apart, right? Or we can regroup. These are all words that I'm sure you've used before. So another thing that your parents would have told you is you can go next door and borrow. And you just have to make sure that when you take this 10 that we're going to borrow, that we're going to decompose, that we're going to regroup, what we do is we take it and we take a 110 and we move it over here. But remember, when we move it over 1, it becomes a 10. So instead of writing 1 or 2 here, this becomes 11. So we know how to do this. This is something you're familiar with. And then you would do 11 minus the 3, and you would get 8. And you do 3 minus nothing is 3. So that's how you're used to subtracting. We can do the same sort of thing over here. But what we have to realize is that we're going to turn our 1s into 5ths. So just like here, we took this 10, we took 110, and we turned it into 10 ones, and then we added it to this one that we already had. So remember, this 11, it's really 10 plus 1. It's the 110 we took from the 4 that we moved over, and then we added the 1, 1 to it. The same thing is going to happen over here, the exact same thing. So what we're going to do is we're going to take this 4, and we're going to make it 3, and we're going to move 1 over. But instead of being a 10, what it's going to be is it's going to be 5/5. It's going to be 5/5 because we have our rule. So again, we're going to move a 1 over, but it's really 5/5 that we're moving over. Now we already have 1/5 sitting there. So what this becomes is 6/5. Okay, so are you ready for the little cheat shortcut? You know what I just realized? I have not given you guys a single code. I'll do it in a second. Okay, so here's the cheat shortcut. I'm sorry, that was a digression on my part. So when I move that 1 over and I add it to what's already there, here's the secret. Just add your numerator and denominator to get your new numerator. 1 plus 5 is 6, and then keep your denominator. That's the super duper shortcut, and we'll do a couple more of these just so you're comfortable with it. But the idea is that you moved 1 whole over, so you really moved 5/5 over. You added it to the 1/5 that was there, so it's 5/5 plus 1/5, just like over here we had 10 plus 1, and that's 6/5. Or again, 1 plus 5 is 6, and hold on to your denominator. So now it's super easy. 6/5 minus 3/5 leaves you 3/5, and 3 minus nothing leaves you 3. So let's do another problem, and again, we're going to do it all 3 ways because I really want you to be comfortable with this. Let's move away from these fifths. I feel like we've been stuck in the fifth world. Okay, so let me bring this down for us. So here's our next problem. We are going to do 5 1/4 minus 3/4, and you can do this whichever way you are comfortable. So I'm going to start with the number line because I like the way that that models it for us. So again, I'm going to go ahead and write this out. I have my number line. I'm going to put my 5 in the middle. I'm going to go up 1 whole to 6, and I'm going to go down 1 whole to 4. So I have 4, 5, 6. Now for this one, I'm going to decompose in the middle. I'm going to do it into fourths because 4 is in my denominator, which also means that my rule is that 4/4 is equal to 1. So let's go ahead and put those in here. All right, so there we go. So we have 1, 2, 3, 4. 1, 2, 3, 4. So we decompose that, right? Or we pulled it apart, or we cut it up, partitioned it into 4 equal pieces. So now let's mark off where we're starting. So for this one, we're starting at 5 1/4. So we're starting at 5 1/4. I move over 1. So now I need to subtract 3/4. So the first thing that happens is to get down to the 5, I need to subtract out that 1/4. So we go 1. Now I'm going to go down 2 more to get to 3/4. 2, 3. Let's do it smoothly. I have to subtract 3/4. 1, 2, 3. So I started at 5 1/4, and I ended up at 4 1/2. And I hope you're also noticing that that is right in the middle, so that's also 4 1/2 is another way to say that. Oh, and I didn't give you guys one of our code words. Hang on. Okay, so our first word is going to be fish, F-I-S-H. Fish, F-I-S-H. Okay, so we modeled this, and let's show it like this, that we subtracted 3/4. So we started at 5 1/4, we subtracted 3/4, and we landed at 4 2/4. So that's the first way that we could do it. Let's do it another way. Let's do it the second way that we've been working on. So we're going to do it horizontally. So we're going to start, sorry, I was just looking at something. We are going to go ahead and we are going to start with 5 1/4. And we are going to subtract 3/4. Let me slide this up for us. So again, our rule is that 4/4 equals 1. And maybe I'll jot that over here for us again. So 1/4 cannot subtract 3/4. One piece cannot subtract 3 pieces. If I have one piece of pie, I can't give you 3 pieces of pie. I would have to cut up a whole nother pie. So what we would have to do, again, we have two choices. One is that we can first go ahead and decompose this into 1/4 to match that. So now those can both go bye-bye. And then when I have 3/4 and I put 1/4 there, I'm going to have 2/4 here. So what that leaves me with, remember, these two are subtracting each other. So it's 1/4 minus that 1/4, it's gone. So what that leaves me with is 5 minus the 2/4. And then what I can do is I can take this 5, and remember I can turn it into 5, sorry, that was my bad, 4 and 1. So those are both together still. And then I'm going to subtract that 2/4 from it. So what I can do is I can work with this 1 minus 2/4 part. Now remember, I'm just going to put the 4 still here. So I still have my 4. I can turn that 1 into fourths. I have my rule, 4/4 equals 1. So that becomes 4/4 minus 2/4. So now 4 minus 2, is 2. 2/4. And I still have my 4. So we end up with 4 and 2/4. So we're getting the same answer. Now, if this is confusing you, let's go ahead and let's do it vertically, because I think vertically just makes a lot more sense for a lot of you. Again, it's what you're more familiar with. So we have some room right here to work with. So remember, we're starting with 5 and 1/4, and we want to subtract 3/4, but we can't do that. 1/4 cannot subtract 3/4. So what we have to do is this 5 is going to get decomposed into 4, and we're going to move 1 over. But we don't want to send it over as one whole. That's not going to help us. We want to turn it into fourths. And so what we're moving over really is 4/4. And that's because we know 1 is equal to 4/4. So does anyone remember the shortcut? Think about it for a second. What was the shortcut that I taught you? Remember, you can just add your numerator and denominator to get 5. 5 what? 5/4. So that's gone now. So remember, this is because we have 4/4 plus 1/4. We took 1 whole from here, turned it into fourths, so we had 4/4 plus the 1/4 that was already there. Shortcut, 1 plus 4 is 5. Keep the denominator as fourths. So now I have 5/4 minus 3/4. 5 minus 3 is 2. 2 what? 2/4. We keep our denominator. And then 4 minus nothing is 4. Okay, so I think you should at this point have an idea of which of these techniques is working for you. So let's jump into some of the problem set. We're going to do some of it together, and then I'll let you guys do the rest of it on your own. So I'm actually going to pause while I go grab that. Okay, so I have our problem set here. Give us a nice clean space to work in. Got my donuts out here that I had, manipulatives. Okay, so for this one, I'm actually going to do what they say here to start. We're not going to do the arrow way. We're going to focus on the number line, and we're going to show what we're doing. So let's go ahead and let's try 1A together. So we're going to do it on a number line. We're going to keep it nice and easy. So I'm going to draw my number line. Give myself enough room to work. And then I'm going to go ahead and put my 3 down right in the middle, because that's where we're starting. Now this one actually we're not going to have to go beyond the 3, but again we're going to follow that rule. 4 and 2. And then I have to go ahead and decompose that or partition it into fourths. So let me go ahead and do that. I'm sorry that's not really even. Oh, sorry. Sure, caught that. So let's go ahead and put in our fourths. Again, denominator is 4, so we need to mark off fourths. Try and get them as even as you can. And now we have to show where we're starting. So we're starting at 3 and 3/4. So here's 3, 1, 2, 3/4. So this is 3 and 3/4. Now we have to show that we're subtracting 1/4. 1/4 just means one hop to the left. Put in your arrow and subtract 1/4. Where do you land? You land at 3 and 1/2. All right, so that was nice and easy. So let's go ahead and let's model another one. Let's model, you know what, let's do this one, and then I'm going to let you guys work on those two. So let's do 1D together. So for 1D, I'm going to go ahead and it's 9 3/5 minus 4/5. So now I can see that I'm going to go past that 9 for this one. So let's draw our number line. I'm going to put my 9 right in the middle. I'm going to put 10 to the right of it. And I'm going to put 8 to the left. So I just add 1, subtract 1. And now I need to go ahead and I need to partition this off into fifths. I need to split it up into fifths because my denominator is 5. So let me grab another color. So here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now what we want to do, I'm going to slide this over so we have a little bit more clear. I need to write where I'm starting. So I'm starting at 9 3/5. So I go to my 9 and I add 3/5. 1, 2, 3/5. And that's 9 3/5. Now we have to show what we're doing. We are subtracting 4/5, which means we're going 4 to the left. So let's show 4 hops. 1, 2, 3, 4. And we have to model that. We have to say what we did. We subtracted 4/5. Now we have to tell where we landed. So we go and we say we're at 8 and 1, 2, 3, 4/5. So we landed at 8 and 4/5. Okay, so that's good. We're doing a great job. So for part of your work, you are going to be doing 1B and 1C. So now let's go ahead and let's take a look at number 2. And it says, number 2 says, use decomposition to subtract the fractions. Model with the number line or the arrow way. Again, I'm going to let you guys do this however you're comfortable. So let's go ahead. We can take a look at A, and I'll work with A with you, and we can take a look and see how they did this one. So for 2A, you can see that they already split this up for us, and I want you to think about what we did before, and why would they have put 3/5 here? Why did they decide to decompose 4/5 into 3/5 and 1/5? What made them decide to do that? Well, if you look carefully, what you can see is that we have 3/5 here. So remember what we were doing? Where we wanted to split this up so that we can get rid of that, so to speak, or subtract that out right away. So now what we're left with is if we take 5 3/5, if we subtract that 3/5, that leaves us with 5 minus 1/5. So now remember though, I cannot subtract 1/5 from 5. I need to get a common denominator, and to do that, I need to split this up into 4 and 1. But instead of writing 1, since I'm dealing with fifths, I know that 1 is equal to 5/5. Let's go ahead and write 5/5. And now I can still subtract that 1/5 from that. So now what we have is 5/5 minus 1/5 is 4/5. And we keep our 4. Again, you could have done this the other way too, where we just do it vertically. I'm going to go ahead and do that for us, just so that you have 2 different ways to work with this. So we could have started with 5 3/5. I should have started lower, sorry guys, minus 4/5. So again, we're going to do the same thing. 3 cannot subtract 4. 3 minus 4 does not work. So we're going to go ahead and we're going to take this 5 and make it a 4, and we're going to move 1 whole over here. 1 whole is going to be 5/5 plus the 3/5, or again the shortcut, take your 2 numbers, your numerator and denominator, add them. So 3 plus 5 is 8. Oh, I'm sorry, I have like no room. I don't know where to write it. I'm stuck. So I'm going to write it here. So I'd have 8, and I'm going to keep my fifths. So this becomes 8/5. Why does it become 8/5? Because I had 5/5 that I moved over plus the 3/5, which is 8/5. So now I can subtract. 8/5 minus 4/5 leaves me with 4/5. 8 minus 4 is 4, and 4 minus nothing is 4. So you can see I'm getting the same answer regardless of how I do it. Let's go ahead, and we could model this on a number line, and you can definitely do that. Let's go ahead and jump down to D. And we can take a look at that one together. So, oh, you know what? I'm going to give you a second code. So the second word is going to be hook. H-O-O-K. Hook. H-O-O-K. So now you have two words. So let's take a look at this one. So we have 2 and 3/8 minus 5/8. So remember that the first way that we can do this is that we can decompose 5/8. And what we would want to do is we want to be able to subtract out that 3/8. So we want to put 3/8 here. So now those are going to be gone. 3/8 minus 3/8. And then we have our 5/8 is going to, sorry. So we had 5/8. We put 3 of them here, which leaves us 2 here. 2/8. So now what we have is 2 minus 2/8. So we'd have 2 minus 2/8. But we can't do that again because we have to get a common denominator. So we're going to take that 2 and we're going to turn that 2 into 1 and then another 1 because 1 plus 1 is 2. But for this one, our rule is going to be all about the 8s. Our rule is going to be that 1 is equal to 8/8. So this becomes 8/8. And then we're still subtracting 2/8. So 8 of those minus 2 of those leaves us 6 of those. And we still have our 1. So our answer is 1 6/8. So now let's do that the other way. Let's do it the vertical way. So again, I'm going to start with 2 and 3/8. And I'm going to subtract 5/8 from that. But again, 3 is not enough to subtract 5. So 2 is going to be a friend and is going to regroup and is going to send something over. So this 2 becomes 1 and 1. So we save 1, we send 1. But again, our rule for this one is that 1 is equal to 8/8. So we're sending over 8/8. The shortcut, 3 plus 8 is 11. 11 what? 11/8. This is gone. And why is that? It's because we're taking 8/8 and adding it to the 3/8. And 8 plus 3 is 11. But again, shortcut it. 3 plus 8 is 11. 11/8. 11/8 minus 5/8, or 11 minus 5, is 6. 6/8. And 1 minus nothing is 1. So there you have it. Two different ways. So let's go take a peek at the next page. Oop, there's that donut that keeps jumping in here. Okay, so now for this page it says decompose the total to subtract the fractions. And it's not telling us, anything other than that it wants us to decompose, which is what we were just doing when we were doing it the vertical way, but also when we were doing the horizontal way. So what they're saying to you here is that you have 3 and 1/8. And they're saying, go ahead and decompose this. Now, what they're doing is, then they're doing this whole extra addition thing. And my feeling is that, especially since we're doing this via remote learning, adding this step is going to be a little confusing. So we're not doing it this way. You can do it whichever way you want. If you see it this way, you are welcome to do it this way. I'm not going to focus on this way. I'm really going to focus on the other 3 ways that we've been doing it. So you have a choice, and you can do it via the number line, you can do it using vertical method, or you can do it the horizontal method, whichever way you want. So let's go ahead and let's try, we'll do one of them together. Okay, so we have 5 and 1/8 minus 7/8. So we're going to do it 2 different ways. We're not going to do it on a number line right now. I think you guys are good on that. But instead, I'm going to go ahead and do it first by decomposing the 7/8. So remember, what I want to do is I want to decompose it so I can get rid of or subtract out this 1/8. So I'm going to have 1/8. So I had 7 pieces. I put 1 there. 7 minus 1 is 6. We're going to keep our 8s. And so now what I can do is I can say, well, it's 1/8 minus 1/8. Those are both gone. And that leaves me with 5 minus 6/8. We don't still have that 7/8 because we already decomposed it. So when we turned it into this, that is basically gone. So now we have 5 minus 6/8. But we can't do that. We need to get a common denominator. So we're going to pull that 5 apart. We're going to make it 4 and 1. But instead of writing 1, I'm going to write 8/8. And again, that's because our rule for this problem is based on a denominator, and it's that 1 is equal to 8/8. So that's our rule for this one. Okay, so I have 4 and 8/8 minus 6/8. So let's group these, let's associate them. So what do we end up with? 8 minus 6 is 2. So we end up with 4 and 2/8. I'm going to write that up here. So now let's go ahead and let's do that vertically. So here's the other way of doing it. So we're going to start with 5 and 1/8, and we're going to subtract 7/8. And again, I cannot do 1 minus 7, so 5 is going to go ahead and split itself into 4, and it's going to send 1 over. And now instead of, like we were talking about before, we're going to have to turn that 1 into 8/8, and that's our rule. The shortcut, 1 plus 8 is 9, and keep your 8ths. So again, 1 plus 8 is 9, and keep your denominator the same. But again, this is made up of 8/8 plus 1/8. It's the 1/8 and the one we sent over, the 1 whole. All right, 9/8 minus 7/8 is 2/8. And I keep my 4 because it's 4 minus nothing. So 4 and 2/8. So regardless of which way we did it, we ended up with the same thing. All right, I want to pick one more of these for us to do. And then I'm going to send you guys off on your own. So let's go ahead and, I don't know, let's do F. F just looked interesting to me. So let's go ahead and jump into F. Actually, we just did 8s. I take that back. Let's do something different. Let's go ahead and let's do G, because G is something I don't think we've done 6th yet tonight. So I'm taking a look at G, and the first thing I want to do is I want to write down our rule, because I want to make sure that we're following it, and our rule has to do with the denominator. The denominator is 6th, so I know that 6/6 is equal to 1, or 1 is equal to 6/6. So let's first do it the horizontal method. So what I want to do is I want to figure out, I want to decompose 5/6, and I want to show that I'm subtracting out that 1/6. And that would mean 5/6. If I put 1 there, I'd have 4 more here, because I had a total of 5. 5 minus 1 is 4. 1 plus 4 is 5. And I'm keeping my 6th. So when I do this, remember that now 1/6 minus 1/6, so those are both gone. We're going to hold on to our 7. So I'm going to bring down my 7, and I have 7 minus that 4/6. So now what we do, so now we're going to take that 7 and we want to decompose that, because we need to subtract this from, we need to get common denominators. So 7 becomes 6 and 1, and then that 1 becomes 6/6 instead. So we have 6/6. So 6/6 minus 4/6. So remember, 7 was really 6 plus 1, but we wrote 6/6 instead. And now what you can see is we have 6/6 minus 4/6 is 2/6. And the other thing we have is we still have our 6. So that's going to be equal to 6 and 2/6. And now let's do it the vertical way. And this time we're going to do it really easily. We're going to use that shortcut right from the start. So we're starting with 7 and 1/6 minus 5/6. And remember, all right, so I cannot subtract 5/6 from 1/6, so 7 is going to give up one of it. So we have 6, and we're going to move 1 over, and we're going to use the shortcut right from the start. 1 plus 6 is 7, and we hold on to our denominator. And that replaces it. So we moved 1 over, and we ended up with 7/6. So now you have 7/6 minus 5/6 is 2/6. And we just hold on to our 6, because 6 minus nothing is 6. So that's 6 and 2/6. All right, so I think we did plenty of examples. You guys have your 2 code words, so make sure that you put them on your work. You can either put them through Cami, or you can write on them and then send me a picture, or you can put it in the private comments, not in the class comments, but in the private comments under your work when you turn it in. Any of those options are good. And that's it. So I hope you all have a great night. Remember, you can do this in whatever way you're comfortable. I do want you to really focus on doing question 3 using one of these 2 methods. I do not want you to use just a number line here. I do want you to really try these other ways of doing it. You can focus on using a number line in question number 1. All right, so check our agenda and check our math work to see which problems you're doing, and I will see you in our Google Classroom. Have a great day. Bye.